Well, now that your machine is all set up and ready to go, let's take a close-up look at the Revo and its 5 basic features. The first feature that we'll take a look at is the XYZ controls. You can slide the carriage along the length of the machine in the X-axis, or you can slide the router back and forth in the Y-axis, perpendicular to the machine, and then of course you can plunge the router up and down in the Z-axis to set the depth of the cut. Now I'm just going to turn this machine around here so that you can see it from the back side as I operate it. As you're cutting, you'll be moving the router in one of these 3 directions, or possibly fixing the router and moving the stock, which we'll talk about in a moment. But if you're going to move the router, you can either slide the carriage like this, or you can lock it down into position. Here we would close the split nut on the back of the carriage to lock it into place. With the split nut locked onto the lead screw, the carriage cannot move left to right unless you crank the handle, which is located here on the left side. Each turn of this handle is 1/4 of an inch, so if you have it positioned at a certain location and you want to move it exactly 1 inch, just 4 turns will move that along. And of course you can read that on this measuring tape on the X-axis. And on the Revo, we use the left edge of the carriage as our pointer. Again, with each turn being 1/4 of an inch, if you wanted to move it just 1/8 of an inch, you would turn it 1/2 of a turn. You'll notice on this tape it does have 2 scales, one English in inches and one in metric. One trick that I might suggest is that you set the machine up so that when the router is positioned on an even number, that the handle is straight down. That way it's very quick and easy to identify each location. I am at 20 inches right now. If I want to bring it back to 19, I can simply turn it 4 turns and end up with the handle straight down, and I know I'll be at 19. The Y-axis is forward and backwards in this direction. You simply position the router where you want it and lock it down with this knob. The Y-axis measured off the front of the router base here. When you bring it to 0, you will be positioned directly over the center of the stock. Now I'll turn this machine back around and let's take a close-up look at the Z-axis, or the plunge router. All plunge routers have a plunge bar and a stop. You can plunge the router down to the desired depth and then set the bar until it touches the stop at this point. Now each time you plunge down, you'll plunge to the same depth. You will also have a scale here for the plunge depth with a pointer. Now the second feature we're going to look at is the adjustable bed. I'll step around to the back of the machine here so that you can see as I make these settings. You want to set the stock so that it's high enough that it'll just clear the carriage. If it's set too low, then you can't plunge the router down deep enough to reach it. So we'll want to raise it here. You can loosen the screw on the bracket here on the back and raise and lower the bed accordingly. Again, if it's too low, you will not be able to reach the stock with the router bit. So we'll want to raise this up till we have enough clearance for that carriage. Once we have the headstock end adjusted, we'll want to adjust the tailstock end as well. If you want to make the bed perfectly level so that it'll be a straight cut, then what we'll do is we'll measure off the top of these 2 brackets. For this setup we use a sliding T-square. Put it on top of the top rail here and then slide the blade down till it rests on the top of the bracket and lock that in place. Now you take that square, position it at this end, and we can simply raise the bed up until it matches. If you want to set the bed on an angle to machine a taper, then you'll refer to the tapering chart, and it will tell you the difference between this point here and this point here for the various angles. Now the next feature we're going to look at are the gears and how to control the spiral. There are 3 components for the gearing system. This first set of large gears you see here is the gear reduction and controls the range. The Revo comes with the standard gear reduction set. The 0.25 gear reduction set and the 2 times gear set are optional. The second component is this piece right here, which controls the direction of the spiral. The gear shown here will create a left-hand spiral. If you wish to change the direction and cut to the right, you will use this assembly right here. Notice that it has two gears versus the single gear in this assembly. So if you replace this assembly with this one, it will cut a right-hand spiral. The third component is the drive gear, and this controls the pitch. The Revo comes standard with 3 drive gears. The largest gear will give you a 2-inch pitch. The second gear will give you a 3-inch pitch, and the smallest gear will give you a 6-inch pitch. If you wish, you can order 4 other drive gears, which would give you a total of 7 pitches. And then by purchasing the 0.25 or the 2 times gear pitch, you would get to a total of 19 different pitches. To change the pitch, you'll want to loosen up the linkage and disengage the gears. Then remove the handle from the end of the drive shaft. Remove the spacer and also the drive gear. Now the desired drive gear goes on first, followed by the spacer. Be sure you don't put the spacer on first, you won't be able to align your gears. The handle goes on last. Now you can go ahead and re-engage the gears. You can also adjust the linkage on this side. If you open it up, it'll disengage the gears here. Then you can actually replace this gear with the drive handle, or you can use the indexing pin without having the gears engaged. Anytime you want to use the spiral, you simply re-engage the gears and lock that in place. Now we'll turn the machine around and take a close-up look at the indexing pin, which is built right into the headstock. When using the indexing pin, you will normally want to disengage the gear on the front side here so that you can rotate the spindle shaft directly and lock it in place with the pin. The pin is spring-loaded, so if you simply release the shaft collar on the pin here, it will automatically try to engage with one of the holes. Then you can slide that pin back, rotate your stock, and lock it back in place. When you're not going to use the indexing pin, you'll simply pull it back and lock it out of the way with the shaft collar. Now the index gear has 24 positions, and that lets you divide it up several different ways. If, for example, you wanted to cut 8 flutes in the part, then you would need to index every third hole. 24 holes divided by 8 equals 3. So we would mark this hole and then count 1, 2, 3 and mark the next one, 1, 2, 3 and so on, all the way around. Then as you index, you can simply go to the marked hole without having to count. If you use a pencil to lay this out, then you can easily erase these marks and lay it out differently for the next cut. Now the fifth and final feature of the machine is the template follower. I'm just going to spin the machine around so we can look at the back side so you can see how to hook it up. The template follower plate will now attach to the back of the router base here. You will need to remove the split nut in order to mount this in place. You also have 4 cap screws with washers that you'll use to mount this plate here on the back. This plate is slotted. We'll start by positioning it right in the center of the slot. That way you can later make adjustments to the position of the stylus if necessary. The template support bracket has a series of holes for mounting templates here, and then it has the hardware with the locking plates to attach it to the rail. It can either be attached to the inside of the rail or to the outside of the rail. We're going to attach it to the outside of the rail to start with. We'll just remove that stop and slide this on the end of the extrusion. Of course, this can be positioned anywhere along the length of the bed. Normally, we're working on stock between centers, so we're going to set it up at this end near the headstock. And we'll go ahead and tighten this in place. You can either purchase templates from Legacy. Ours are laser cut and they're made out of steel, so they're very durable, or you can simply make your own, like I've done here. This piece was made out of 1/4 inch masonite, which is double-sided. This works extremely well. It's easy to cut into sand. You'll notice that you'll need a couple of mounting holes, and from this edge has to come up 5/8 of an inch. And of course the holes on the mounting bracket here are in 1 inch increments, so I've drilled a hole here, and they're 8 inches apart. And then we can go ahead and attach this right to the support. Now let's take a close-up look at this template, and I'll show you the maximum and minimum dimensions. From this edge, if you measure out 1 3/4 of an inch, 1.75 inches, that will be your center line of your part that's mounted between centers. So that's the minimum diameter. If you cut this template so that it comes all the way to that line, you would actually cut the part in half. Now the maximum is from this edge is 4.25 inches. Now these numbers are based on the idea of using a 1/2 inch stylus and a 1/2 inch diameter 2-flute straight cutter to cut your pattern. If you switch the stylus to the optional 1 inch diameter and used a 1 inch cutter, the numbers change. Because the 1 inch cutter is larger in diameter, this center line is actually at 2 inches instead of at 1 3/4 of an inch. And your maximum here would go down to 4 inches as opposed to 4.25 inches. Keep in mind that you always want to match the diameter of the cutter to the diameter of the stylus. Let's turn the machine around so we're on the operator side and take a look at how the template's going to work. First of all, you want to move any stops in the y-axis so that the router can simply float back and forth in this direction. And of course we've got our 1/2 inch stylus in here, so we'll go ahead and insert it and lock it down. And then with the router just floating, we bring it into the back side up against the template, and you can pull that in against the template as you slide it along the length like this. Now the template follower can be used with stock between centers. When you're turning, you can either turn it round or index it, make it multi-sided, such as square, following the contours, or you can use it on flat stock and molding. There are 3 router bits that you will want for this part of the training. The first is bit number 2704. It's a surface planing bit. The second is 3952. It's a classic spiral bit. And the third bit is 7581. It is a 1 inch rope molding bit. You can order these bits directly from Magnate. To create the first part, you'll want a piece of stock 1.5 inches by 1.5 inches by about 12 inches long. Now you can either leave the part square, or you can use the table saw to cut off the 4 corners to make it octagonal. The second option will create a lot less wear and tear on your router bits and a whole lot less sawdust once you start machining. On the tailstock end, we've simply found the center and drilled a small hole. At the headstock end, we've actually drilled a couple of pilot holes in this hard maple and then used some screws to mount the indexing hub on the end of the stock. The next step is to loosen up the tailstock so that we can position it along the length of these rails in the front here. And we'll take the part with the index hub on this end and insert it into the index drive. Then we'll slide the tailstock up until it supports the stock. Notice that I have the handle parallel to the tailstock, or straight down like this. If you have the tailstock handle open too far, when you lock it down and close it, it'll put too much pressure on the part. So again, we'll have it till it's just about straight down or parallel with the tailstock here. At this point, we'll go ahead and tighten the tailstock in place. And then we'll close it all the way, and that'll put just enough pressure to hold this part in between centers. To mill this stock round, we need to rotate it as we move the router, but we're not going to go through the gear sets quite yet. What we're going to do to start off with is to change this gear for the drive handle. So we'll open up the linkage here. Then we'll remove the index gear from the spindle shaft. And we'll replace it with the drive handle. Now the spindle shaft handle has a rectangular hole, so it will only go on the spindle shaft. Next, we want to set the adjustable bed. We want to raise it as high as possible so that it'll clear the carriage like this, but we need to make sure it's level. So we'll check this in, and I've raised it up till it just clears the carriage here at this point. So we'll go ahead now and make sure that both ends are exactly the same height. Again, the way to do this is to use the sliding T-square. Just drop it down till it rests on the bracket at this end. Once you have that set, we'll simply set it down at this end and then adjust the bed so that it's the same. With the bend set to level, we'll go ahead and change our router bits. And we're going to use bit number 2704 as the surface planing bit. Now if you use the optional eliminator chuck, changing the router bits is extremely fast and easy. Now just plunge the bit down till it rests on the surface of the stock. Now set the plunge bar. We'll go ahead and make a test cut right here at this plunge depth. So we'll just slide it down towards this end. I have the router off to the back side, so when we turn it on, we'll bring it slightly over center as I'm rotating the stock, like so. So you can see we've turned it round all the way. What you want to look for now is to make sure there's no flat spots that are left. If there are, you'll need to reset the plunge depth onto that surface. So let's go ahead and reset it on this surface right here. It's very close. I've got just a little bit of a flat left. So we'll slide the router bit back over the top of the part, plunge down onto that surface that we want to set our plunge depth, and reset the plunge bar. Now I'll show you a trick. If you want to take off a certain dimension, say 10/1000ths of an inch, Legacy sells a set of feeler gauges that were designed for machinists. We'll select a 10/1000ths inch feeler gauge and then place that between the plunge bar and the stop. Now we have a 10,000th spacer between there. We can reset the plunge depth and cut off an additional 10/1000ths. We're now ready to mill the stock around, starting at this end. You want to bring the router bit in until it's a 1/2 inch off center and lock it in place. When you turn on the router, you want to make sure that it is not touching the wood. So we'll slide it off the end of the stock. Be careful not to slide it up so far that you'll run the bit into the tailstock. In fact, it may be a good idea at this point to set a stop. To limit the movement of the router in the x-axis. At the headstock end, you'll want to set a stop here on the back side. So when the carriage comes to 2 inches from the headstock end, it'll stop. That'll keep you from running the router bit into the spindle shaft. Normally you would operate the machine from right here in front. But for the video purpose, I'm going to step around to the side so that you can see what's happening as I make this cut. I'll turn on the router, and then I'm going to rotate the stock clockwise. And I'll simply pull the router towards me, moving it about 1/8 of an inch per rotation. Now just one note of caution. You never want to make the mistake that I just made and not wear your safety glasses. Whenever you're cutting with the router or any other power tool, make sure you use the proper safety equipment. This technique will give you a perfect finish. In a moment, we'll show you how to use the gears to drive the router along the length as you rotate the stock. For the next step, we're going to change the router bit. We'll use Magnate's bit number 3952. Which is the 2-inch diameter classic spiral cutter. For the rest of the cuts, we'll simply reference the surface of the wood. So we'll take this router bit and turn it perpendicular to the stock and plunge it down till the shoulder of the bit is just resting on the surface. Lock the plunge bar in place. Now for this cut, we'll want to start from the back side and cut out till we come to the center line. So we'll bring the router out till it's at 0 on our y-axis scale. And I'm going to set a stop right here so that whenever I bring it up to the stop, I know I'm at 0. Now go ahead and slide the carriage up until the left edge is measuring at 6 inches on your x-axis scale. Then we'll use the split nut to lock it in place. Now I'm going to turn the machine a little bit so that you can see better what's going on here. The idea is that we'll want to plunge the bit down on the back side so it's not touching the stock, and then slowly bring it over center as we rotate the stock in a counterclockwise direction here. This time we'll be sure we do not forget the safety glasses. This next part, we're going to cut some flutes into this end of the stock. So we're going to remove the handle and replace it with the indexing gear. Now we'll need to release the indexing pin. The indexing pin is spring-loaded. So once we release the shaft collar, this pin will just drop into one of the holes and lock the part stationary as we make our cut. Now slide the carriage forward until it is centered over the part, and then we'll plunge just the tip of the bit down until it touches the surface of the wood. Now we'll set the plunge depth to cut the flutes. I'm going to use the feeler gauge here. We're going to go to 75 thousandths of an inch, and I'll simply put that spacer between the plunge bar and the stop. Now if you don't have a set of feeler gauges, you can simply go by the scale on the front of your router here. Now if you don't have a set of feeler gauges, you can set the plunge depth using the scale on the front of your router. You'd want to set it for about 1/16 of an inch deep. The next thing we'll do is set a stop to limit the length of the flute. We'll come down here to 4 3/4 of an inch and then set the stop on the back side. Now with the stop set, we're simply going to slide the router back and forth between the stops at 4 3/4 and 2 inches. The router is centered over the stock, and so we'll lock it in place at this point, and we're ready to make our first cut. Again, don't forget the safety glasses. Once you've made your first cut, we're going to move the indexing pin a total of 3 holes. So we'll release the pin, rotate it 1, 2, 3 positions, and make our next cut. The indexing gear has 24 holes in it, so by going every 3rd hole, it'll give us a total of 8 flutes. Now you'll notice with this cut, I plunge down, cut to the stop, and then machine back to the starting point and bring it back up. And then we'll go ahead and index to our next position. Now we'll continue this process until we've cut all of the flutes. Now we're ready to make the setup to cut the rope design. Now to start with, you'll lock the indexing pin back out of the way. So that you can rotate the part. Then we'll go ahead and just engage the gears. Now you want to make sure that they are fully engaged so that you can cut the spiral. For this rope design, we're going to use a 3-inch pitch, so be sure that you have the middle size or B drive gear. You also want to make sure that this gear is fully engaged. At this point, you'll want to move the stop on the x-axis out of the way so that you can slide the router along the full length. And we'll go ahead and set up with Magnate's bit number 7581. This is a 1-inch rope molding cutter. Again, we want to plunge the shoulder of the router bit down until it's just touching the surface of the wood. And then we'll set our plunge bar. Now we're going to bring the router over center. We're going to lock it down in place. Then we're going to move the router back to 6 inches on the x-axis scale and lock it onto the lead screw. So the router can't move along the x-axis unless you turn the handle. You're now ready to cut your first pass, or what we call the first start. We'll go ahead, turn the router on, and plunge down the full depth, and then we will turn the handle on your x-axis screw counterclockwise, which will drive it from the 6 inches down to the end of the stock. That completes the first start. You can see the distance that the router traveled from one point to the next point over one rotation is 3 inches. That's our 3-inch pitch. Now to form the rope, what we'll need to do is take the router bit out of this cut and move it back 1 inch, which is exactly the width of the router bit. At this point, you want to open the split nut on the x-axis. And you want to slide the router back 1 inch. We are sitting at 14 inches right now, so I'm going to slide this back to 13 inches along the x-axis and go ahead and lock the split nut back in place. Now we're ready to crank the router back up to our starting point. Again, we'll start at 6 inches and plunge down and make the next cut. Now you can see how it has moved over 1 inch and formed the bead. So we'll take the router bit, again move it back 1 inch exactly the same way and cut the third and final bead. So we'll open the split nut on the back side. Notice where we are on the scale. Again, we're at 14 inches, so let's slide it back to 13 inches one more time and lock it back on the lead screw, and then we'll crank it back to our starting point. And we're ready to make our last cut. There's your 3-start rope, your 8 flutes, your turnings, and of course we started off by just machining the stock round. Well, with this part we learned the basic features and functions of the machine. Turning the stock round, cutting beads and coves, using the indexing to cut our fluting, and of course the spiral drive to cut the ropes. For more detailed instructions, you can go to our website at legacywoodworking.com. You can look under the training and find instructions on hollow spirals, barley twist, rope designs, fluting, reeding, custom moldings, and much more. You can also sign up for our e-magazine, which will give you online woodworking classes at no charge. Again, you can sign up at legacywoodworking.com.